following videotape was produced by Digital Equipment Corporation. The IPC gratefully acknowledges his contribution to the electronic interconnection industry.
The printed wiring board serves as a vital link between the semiconductor and all the exciting new electronic products that are changing the lifestyle of America and the world. Computers, telecommunications equipment, complicated instruments, automotive applications, and a variety of consumer-oriented products. This videotape provides you with the details of how high-quality printed wiring boards are produced. As you watch the sequence of production, two things will become clear. First, the need for significant investment, not only in the plant itself, but for the materials and equipment needed for production. Secondly, the need for well-trained people who care about the quality of their work. As you view the production process of the printed wiring board, you'll see that many different talents are required to produce the final product. It's a team effort that requires the best in equipment, a thorough knowledge of the process, and people who take pride in producing a quality product. Let's take a look at how a printed wiring board is manufactured. A printed wiring board starts out as a piece of fiberglass with a thin layer of copper on each side. After this copper-clad material is thoroughly inspected, it's released to production. The first production area is pre-bake or stress relief. First, the slip sheets are removed from between the panels. The slip sheets prevent damage to the copper surfaces. The panels are loaded on a cart and then pushed into an oven. The panels will be baked for approximately 6 hours at 300 degrees Fahrenheit. The baking cycle will dissipate any moisture trapped within the material and prepare the panel for further processing. After pre-bake, the panels are stacked in groups of 4 and pinned together. Along with the panels, a piece of entry material and backup material is added. The entry material will provide a smooth and even surface for the drill bit to enter. The backup material reduces burring and prevents damage to the tooling plates of the drilling machine. Following the stacking operation, the panels enter the drill prep area. Here, the lot is logged in, and the proper drill tape and blueprint are placed with the group of panels to be processed. Once the proper materials are issued in drill prep, the panels move on to the drilling operation. This operation utilizes CNC equipment. CNC stands for Computerized Numerical Controlled. A computer controls the machine and tells it where to drill the holes. All information necessary to drill the wiring board is coded on a computer tape. Once the tape is fed into the reader of the computer, the program is stored, and the computer then controls all functions of the drill. After the drilling cycle is complete, the operator refers to the blueprint to make sure the machine has done the job correctly. To verify the accuracy of the drills, a machine checks the exact location of the drilled holes as measured by the quality control inspector. From drilling, the panels enter the deburring area. The deburring machine utilizes coarse bristle brushes to remove any burrs created by drilling and roughens the surface of the panel for later processing. Next, the panels are subjected to a high-pressure water blast. This will wash away any dust or debris generated by the act of drilling. After rinsing, the panels are thoroughly dried, inspected, and returned to the proper tote. Whenever panels are handled by the operator, gloves are worn to prevent contamination of the surface of the panel. The panels now enter the first chemical process, which is electroless copper deposition. It's called electroless, by the way, because the copper is plated onto the surface of the panels and inside the holes without electricity. In this process, the panels are cleaned, sensitized, and chemically plated with about 100 millionth of an inch of copper. The first thing you notice about this operation is the massive size of the plating line itself. There are many chemical tanks, and quite a few of the tanks are water rinses. Cleanliness is directly related to quality. After electrolysis, the panels travel to the image prep area. Here, the panels are chemically and mechanically cleaned. Again, you'll notice all operators are wearing gloves. The panel surface must remain free of any contamination because in the next operation, the panels will be coated with a photosensitive dry film resist. Any contamination will directly affect the adhesion of the dry film. This dry film resist is laminated to both sides of the panel. Heat and pressure are used to help promote adhesion. The dry film is called resist because it will resist plating, which will occur later in the process. The yellow lighting in the room is necessary because the dry film is sensitive to ultraviolet light. Basically, by laminating the panel with photosensitive material, we have transformed the panel to a piece of film, waiting to become a picture. That picture, of course, is the printed circuit pattern. Now, the panels are ready to be processed in photoprint. 2 pieces of polyester artwork, which contain the circuitry image, will be placed on each side of a panel. The artwork, along with the panel, is affixed to the pinning fixture within the exposure unit. If the drilling was performed correctly, the land areas on the artwork will surround the holes in the panel. This alignment is known as registration. Once the registration has been verified, the panel is subjected to an intense ultraviolet light. We now have a picture of the circuit board. Since we've taken a picture, naturally, it must be developed. The panels can now be processed through the conveyorized developer. The solution in the developer will attack and dissolve all dry film not exposed by the ultraviolet light. After developing, the panels are thoroughly rinsed and dried. What we have now is an almost perfect duplicate of the desired circuitry. The bare copper areas will receive additional platings in the next operation, which is pattern plating. The name pattern plating tells us what's happening here. The circuit pattern will be plated, first with copper and then with tin lead. This plating process is accomplished through the use of amperage. Earlier, in electrolysis, the plating was performed by chemical means only. Since the platings must be heavier here, electricity is used to help it along. Operators here must watch the rectifier settings very closely, as in all areas, the operators, a team of technicians and engineers, are constantly monitoring the process and equipment. From pattern plating, the panels move to strip and etch. When placed on the conveyor of the stripper, the panels travel into a chamber which sprays a solution onto the top and bottom of the panels. The solution attacks and dissolves all dry film remaining on the panel. After stripping, the tin lead covered circuitry is clearly evident along with the base copper. The next operation will remove that copper. As the panels travel into the etcher, the alkaline etching solution attacks and dissolves all the copper not covered by tin lead. Now the panel begins to really look like a printed wiring board. We can clearly see the circuitry, which is on a non-conductive fiberglass board. It's now truly a double-sided wiring board. The plated through holes allow electricity to pass from one side of the board to the other. Many of these printed wiring boards are designed with printed edge contacts. This allows the board to be connected by the edge or easily removed from equipment. These types of boards require additional processing. These edge contacts will be gold-plated. Gold is used because it's durable, does not oxidize, and is an excellent conductor of electricity. First, the printed edge contacts are stripped of tin lead. Next, the copper remaining is scrubbed and rinsed. Now, approximately 100 millionths of an inch of nickel is plated over the copper on the contacts. The nickel plating is necessary because the copper would oxidize and attack the gold. The nickel seals the copper permanently. After nickel plating, the contacts are plated with approximately 50 millionths of an inch of gold. Since this is a critical contact point, inspectors use very specialized devices to accurately measure the thickness of the gold. The next step in the fabrication process is infrared fusion. In this area, an infrared lamp is used to metallurgically bond the tin and lead together to the surface of the copper. Not only does this help protect the circuitry, it also creates a good electrical connection which can be easily soldered. Because the panels are subjected to a high temperature, operator awareness is extremely important in preventing damage to the circuitry. Now we have our desired tin lead plated circuitry in place on the fiberglass board material. During the assembly process, components will be added to the board. Many times this will entail additional hand soldering. To prevent solder from falling onto the circuitry, an ink called solder mask is applied to the wiring board using a semi-automatic silkscreen machine. Activating the machine causes the flood bar to coat the screen with ink. Next, the squeegee moves across the image area, forcing the ink through the screen and onto the surface of the panel, leaving only the holes uncovered. The operator is the key to quality screen printing. After a visual inspection, the panel is placed on the conveyor of the ultraviolet curing unit. The ultraviolet radiation will cure or dry the solder resist. Throughout the process, the printed wiring boards have been manufactured in panel form. One panel may contain only a few or as many as 100 printed wiring boards. The NC routing operation separates the wiring boards from each other and the panel itself. The NC routers are very similar to the drills. Rather than performing a drilling function, the routers cut the boards out in the proper dimensions as specified by the blueprint. As in all areas, a quality control inspector checks the work to be certain the job is performed correctly. The job cannot continue until the quality has been verified. Throughout the process, the quality has been constantly monitored. Before any boards leave the facility, a final inspection is performed. Every board is visually inspected. Hole sizes are checked, along with registration, solder mask, and outside dimensions. Not only must the boards function properly, they must exhibit the appearance of a quality product. Along with the visual inspection, the boards are tested for electrical continuity. Once the boards have passed the rigid inspection, they're sent to shipping. Each board is individually packaged in plastic, placed in boxes along with a shock-absorbing foam, and shipped to various customers. Earlier, we looked at the chemical processing area. Because this is a chemical process, all chemistry and water must be rendered harmless. Also, as the chemistry is depleted, it must be dumped. Notice the plumbing attached to the equipment? This all leads to a very important area, waste treatment. In this area, all chemistry and contaminated water is piped to various holding tanks where it is neutralized. Any metals suspended in the solutions are also removed. Before any liquid is discharged, it's analyzed to be certain nothing harmful is released into the environment. The wastewater, as well as process chemistry, is analyzed in the lab. Many pieces of highly specialized equipment are used. Engineers are constantly searching for better or more efficient ways of chemical control. Many hours are spent researching new information and the latest EPA regulations. We've seen the process steps necessary to fabricate a quality printed wiring board. In addition to operators, there are many other groups necessary to support such an enormous operation. To monitor the process, there is a battery of process technicians and engineers. This group is responsible for maintaining the rigid process controls. Naturally, someone must maintain the equipment. The facilities group handles the day-to-day maintenance of the machines, as well as preventive maintenance programs, to prevent problems before they happen. In addition to process support, there's a large administration staff to support the operation. Along with process engineering, there's project engineering, administration, finance, shipping and receiving, purchasing, personnel. All these groups must work as a well-practiced team. Without this teamwork, not one single board would make it through the process. In this age of changing technology, thorough training is necessary. A training department provides the latest information concerning the process. Computers are a way of life in the business world. The Systems Group maintains the computer network and creates the programs for many areas in the facility. We've now taken a look at the printed wiring board process as it stands today. New technology is discovered almost daily. As this occurs, it's necessary to update the process and replace equipment. But one part of the process will never change, and that's people. Proud, quality-minded people can never be replaced. America's future in the world market will indeed be competitive. To continue to be leaders in the electronics world, the United States must produce highly reliable quality products. If your company is a producer of printed wiring boards, one thing is certain. Part of its future success depends upon you.